picking up where we left off, we know that our radius of convergence is 3. All right, so if we turn this into an interval, we make it into a compound inequality, we can see that x is between -3 and 3. All right. Now we know that the ratio test works when the result is less than 1. We know that the ratio test diverges, or says the series diverges when the result is greater than 1, and the ratio test is inconclusive when the result equals 1. So we don't know whether or not we need equal signs underneath these inequalities. Okay, we have to test those values out, and we can't use the ratio test because the ratio test is specifically inconclusive when that happens. So we have to basically plug in our endpoints, and we have to use some other test to help us determine whether or not we should include the endpoints in our interval of convergence. Right? So we have two cases here. The first case is what happens if x is equal to -3. So what does it mean? We're literally going to plug -3 in for x into our series and go from there. Right? So what we're looking at now is the sum as n goes from 0 to infinity, and I'm going to replace x with -3. So I actually have the square root of n times -3 to the nth power over 3 to the nth power. All right, and I have to come up with some kind of test that's going to show me what's happening right here. All right. Well, you can kind of see what's kind of, we got this -3 to the nth power. However, that could also be rewritten as -1 to the nth power times 3 to the nth power, because we know that -3 is really just -1 times 3. Okay. And these 3 to the n's now eliminate each other, so we end up having the series of -1 to the n times the square root of n. All right. Well, that seems like a classic nth term test there, where the limit as n approaches infinity of our series, if it does not equal 0, then the series will diverge. And when n gets really, really large, this series definitely is not heading towards 0. All right? So the series will diverge at x equals -3 because the nth term test is telling us that we definitely have divergence when we plug in that value for x. All right. Well, the same thing happened when we plug in 3. Well, over here now we have the sum as n equals 0 to infinity, just like before, but now we're going to plug 3 in for x, so we have radical n times 3 to the n over 3 to the n. And you can clearly see that once again our 3 to the n's are out of there, so we're interested in the limit as n approaches infinity of just the square root of n, which once again is not 0. All right, so in this situation, the nth term test is telling us that our series will diverge when x equals 3 as well. So we are not going to include the endpoints, either of them, for our interval of convergence. Our interval of convergence is any value between -3 and 3. If x happens to be 3, the series will diverge. If x is 3.1 or 4 or 4 million, the series will diverge. It will not be matched up to our function. Okay? However, if x is in between -3 and 3, then the series will converge to our function.